So I am making this extra video as sort of a condensed review. I think some of us are still struggling with some of the rules and remembering when to use them. So this is going to be just a general overview. You're not required to watch this, but this could definitely help you. I'm going to first start by going over each of the rules that we have learned about, and just a simple example for each one. So the first one that we have is the product rule. So the product rule tells us that if we have like x to the fourth times x to the first, that we want to add the exponents to get x to the fifth. So the product rule tells us to add. And we do this when we are multiplying. So when you see that dot there, that means multiply. We use the product rule and we add the exponents. Next is our power rule. So if we have like x to the third to the second, when you have a power to a power, you are multiplying those exponents. So this would be x to the third times 2, so x to the sixth. And the power rule tells us to multiply. And you do this when you see a set of parentheses. So when you see the parentheses, it has a power to a power. That's our power rule, multiply exponents. Next we have the dividing rule. So let's say we have x to the ninth over x squared. When we have the dividing rule, we subtract the exponents. So we would get x to the seventh for this one. Now this kind of goes also with negative exponents, so I'm going to put that next to this. When we have something like x to the negative 3, we don't want negative exponents, we only want positive, so that would become 1 over x cubed. So whenever you have a negative exponent, it's going to become a fraction of some sorts. All right? So those are the rules that are most important to remember. And the most important thing as well to remember with all of this is that it is only with like terms. So that means like x's and x's can be combined, and y's and y's. But you cannot combine x's and y's. I saw some people trying to combine, like trying to add those. You can't do that because those are not the same variable. All right, so like terms or variables. So that's a general overview. I want to do a few examples that show those things, and some things I've been seeing on the review that have been confusing a few people. So I'm going to start with, if you're looking at your review, I'm going to do number 10. So we have 8m to the fourth n to the seventh all over 4m n to the third all to the negative third. So there's two ways you could do this. You could apply this negative 3 to each thing on the inside, or you can simplify the inside first and then apply that, which that would be easier, so let's do it that way. So first, we're going to simplify our whole numbers. So we have 8 divided by 4, which is 2. So I'm going to leave this in my set of parentheses here. I'm just going to go ahead and write out my set of parentheses because I'm just simplifying what's inside right here, and I'm going to put it down here. Okay, so next let's look at our m's. So we have m to the fourth and m to the first. Remember there's that invisible 1 there? So that would be m to the 4 minus 1, which is really m to the third. Okay, let's go on to our n's. So we have n to the seventh and n to the third. So we would have n to the 7 minus 3, which is really n to the 4th. And then move this over there. So now we've simplified our inside. So that highlighted part became this new highlighted part. Okay, let's go on to our next step. Now we're going to apply this -3 to each term on the inside. And when I say each term, I want to show you what I mean by that. So people were getting confused on that too. So the number 2 is its own term. This m to the 3rd is its own term. And n to the 4th is its own term. So we're going to apply this to each of those. Some of you like to say kind of distributing it. That's kind of like what we're doing. So we would have 2 to the -3. Now just write this out. Don't worry about the negative yet. Just write it out. M to the 3 times -3 and n to the 4 times -3. I'm going to simplify this down. I'm just going to simplify the variables down first. Okay, now let's start with just simplifying down our 2 to the -3. So we don't want negative exponents, we're going to use our rule. So we want to turn this into a fraction, 1 over 2 to the 3rd. When you turn this into a fraction, that negative sign in that exponent disappears because we've put it in the bottom. Now we have m to the -9 and n to the -12th. We don't want negative exponents, so these need to go into the bottom of the fraction. Now we already have a fraction here, so I'm just going to extend out this line, and now I'm going to put those in the bottom. And now all we need to do is simplify that 2 to the 3rd. So use your calculator if you need to. 2 to the 3rd is 8. So our answer is 1 over 8m to the 9th, n to the 12th. Okay, so I went through that problem pretty in depth to try to help you figure things out that had, I think, almost had all of the rules in it. So remember these rules for your test and take a look at this problem. Hopefully this will help you.